Welcome to an episode of PX and the Art of Programming. PX is a project that I started in 1988, and the target, the aim, the goal was to come up with a piece of software with which an information system could be set up. And the quality of the information system should be as high as possible. And with quality I mean user-friendliness and stability and correctness. And to make an information system correct and stable, it is demanded that the amount of software written specifically for the information system is as small as possible, because every piece of metadata, by which I mean programming statements, introduces a risk. And the risk, of course, is that the programmed statements are wrong or inaccurate. An information system is a storage of data which users can modify and can search in. An example of this is an information system that I wrote for my friend Wim. And my friend Wim makes a lot of films of bands, performers here in Arnhem. And this is the website that I created for him. The interface is minimalistic. And the purpose of this interface, the minimalistic part of it is that it should be easy to click and watch what you would like to watch. This is an alphabetic ordered list of bands, and the band that I play in is totally at the bottom. It's called, here it is, 4 Man Sterk. It's a Dutch band. I am Dutch. I live in Arnhem. Well, not everybody wants to scroll all the way down, therefore you can type in just some letters and then with the arrow key, move down below and go for 4 Man Sterk. Then you hit the enter button and then you will see all the recordings of this band. And that's me on the right hand side. This is Gert, the lead guitar player. He passed away this year. I'm very sorry for that. There's René, the bass player, and this Wout, the drummer. Oh, we have some recordings, as you can see. And you can also click. De Grote Boodschap, for instance, is a Dutch punk rock band. A very great band. You can click on these links. I won't do it. It's just a normal YouTube link. That's it. That's all the interface offers. That's all that's needed, by the way. Well, now have a look at the inside of it. I will log in to the database using the account of my friend Wim. For this I use my very secret master password. And this is the screen, the interface with which Wim works. It's in Dutch. But I'm Dutch and Wim is Dutch. But this can be made multilingual. No problem. I will translate it for you. This means insert a new movie, a new film, a new... and this is a series. And to insert a new film, you have to give a date. You have to tell the system which band it is. Then the location where it was taped. The videographer, only one option. That is my friend Wim. And then the YouTube embed info. What Wim does, he uploads the movie after he processes it first on his own machine, does some improvement on the sound, some improvement on the video quality, and then he uploads it to YouTube. And then he asks for the embed information and pastes it in this field. This is a one-time event, a series, to insert a series. That's the second button. Then you can just go ahead. If you enter and the entrance is correct, for instance, if I enter on a completely empty screen, then it will raise some errors. And it will tell you that the field date is mandatory. Verplicht is Dutch for mandatory. The field performer is mandatory. The field location is mandatory. And the field YouTube embed info is mandatory. So you cannot enter any data which is inconsistent. And this is not programmed especially for this application. This comes from the central machine. Here you have a list with all the videos, all the films that Wim has entered, meaning he has uploaded them to YouTube and he entered an entry in this database. Because on his YouTube channel you will see 944 movies, or maybe even more. Well, there is no way for a specific band to look up their own films. So 944 lines. Regels is Dutch for lines. I pick up just one line. This is completely filled in by Wim. Here's the date entered, the performer, the location, the videographer being Wim himself. Here the YouTube iframe info, the embed info. And here a preview in a designated size. And a description here below. That's all Wim does. And he maintains a list of the performers. Here you can see the formula of the dust bombers, and they have 1, 2, 3, 4, 5 videos over 2 locations. Just pick another one. Zarita, only 1 movie. Zen HR is also 5 movies. The videographers only 1, being Wim, and the locations. This button will take you to this interface. So Wim can check how things look for the outside. And the number of visitors. So here we have an export of data, a thing that Wim asked me for, because it's nice that everything has been coded into this database. But he wants to have an export for himself. So and I will just choose. I'm working with a Macintosh, I haven't told that already, not yet. This is my favorite text editor. This is the data. It's tab delimited data. And if I move over to OpenOffice and I ask for a spreadsheet and I paste it, then this is the complete data. The ID number is a meaningless number. It's automatically incremented. The performer is the name of the band or artist. And the location, of course, videographer, the embed info. Quite long, of course. And then the description. But you get the picture, don't you? Like a kind of backup for Vim, just in case. Well, that's what you can do with it. I will show you some of the programming that I did. This is the same server. It runs here locally on my network. And instead of the database db2hands2, I'm now using a database that's called lbpx. LB stands for library. It's a database like any other database, but it is meant to hold metadata or programming data. And I'm logged in my own account. And here I have stored all the programming stuff for the application that I made for Vim. This is all the software that was needed to produce this interface. And that's it. So it's not a long program. Huh? Of course, it is mostly HTML for the design. I won't go into all the details of this. Just to show you that it's not much programming. This is one piece of the program for the management screen. And the other one is the export function. If you hit this button, you will get this plain text data. And that is defined by these two statements. A header line and a data line. Right. That's all the programming needed to produce the interface. The web is a little bit complicated, more complicated. It has 3 interfaces defined. And the main one is a table with 2 columns. As you can see here, there's one column holding movies, one column holding the names of the performers. And if we go to the movies, then no, this is not such a large program. It will display a single movie. And this will display all the performers. Also not very huge for a program, don't it? Huh? I can guarantee the workings of this interface for 100%, including the little bit more complicated stuff like this. With all the sort options, you can sort on date, you can sort on ID, you can sort on performer, you can sort on location, videographer, description, and you can just skip through the pages. That's the idea. Here you can edit, a series edit, you can delete a series of movies, you can enter a new movie. There's also an import function with which you can import plain text and a find option. So I want to find everything between, let's say, January this year until February. March, okay? 1st of March this year. Then these are the performances. Radio Gideon. With this, I have not only made this small application for Vim, I also wrote huge applications for big companies like Pfizer Pharmaceutical. I don't do that anymore. But it was good enough for them to use. All these other interfaces that I've written all concern logistics and finance. And I won't go into that at the moment. Apart from the interface definition, it is also needed to define the tables with which you work. And what Vim needed was a table for the videographer, holding only one real field, namely the name of the videographer. And the other field is a primary key field, but it only contains a number, a meaningless number. And we have a table for the performers. And lastly, the movies. And the table with the movies is the one with the most fields, because per movie you have to enter a date, just one, and then the performer, this one, the location, this one, the videographer, the YouTube embed info. And then here the field that you don't have to enter, that is the embed info, but then in a small variant. And for this I've written a function to size the YouTube embed info, to resize it. And a description box. So, that was just a fly around to show you that it does not take much programming to set up a system like this. And if you start to work with MySQL or WordPress or whatever, you will need a lot of more programming, to my humble opinion. Well, after this intro, I will now go into the main subject of this talk, and this talk will be on the subject px1micro. Being an introduction video, what you are looking at is an Xcode project. And the project is called, let me show you. It's a single file. If you are familiar with Xcode, then you will know about this. It's a .xcode Xcode project. And its name is, of course, px. px is an acronym of Project X. Project X. I used to have a firm long time ago, and every project had a number. And then I decided that I wanted to have a project without a number, an anonymous project with which you can build whatever project you would like. Hence the number X and P for project. By coincidence, px also means logos. It's Greek, meaning it means language. I have a Bible here. I'm a Bible-believing Christian. I have a Bible here in house, and it has the symbol px. where the P stands for an R, the Greek letter rho, and the X stands for a G, G. So it's G, G. So a rho is an R and the X is a G. That was a coincidence. Well, if you want to write an ideal program, the last thing that you would want is hassle about numeric values, because there is a problem with numeric values. For instance, if I write in the programming language C, is this handy? Can I, wait a sec. A becomes see if I can. This doesn't work. No, I cannot make it larger. That's a pity. Well, let me switch over to OpenOffice. Bear with me. This will take some time. Anyway, this is a valid. This is a valid statement in C, isn't it? Huh? A becomes 34 plus 78. This is also a valid statement in C. But this is a dangerous statement, because the language C does not guarantee that A will be the sum of B and C. It sounds like a huge accusation, don't it? But it is true. For instance, if this was the definition, char A char C, and A becomes unknown, not needed. 192. C becomes 192. What will be the value of A? Well, the value of A will not be 384, because A has been defined as a char, as a 1-byte variable. So what will be the value of A? Well, it will be 384 modulus 256. LS. And this is not something that you would want in an information system. If you have a really complicated series of functionalities, then you don't want to have to bother about these trivialities. And believe me, that these things will happen even if you work with something like unsigned long. You have the same problem. You cannot in this case, you can guarantee the working of this statement, of course. Huh? But if I change it to this, how are you going to guarantee that this statement will produce the right output? In this specific case with B 192 and C 192, of course. A will be 380 and 384. But it could be that B is produced by some kind of function of which you don't know the meaning of the function. You call it the intention as the logic word. And for C can have the same problem. So you don't know the real value of B or C at any given moment. The only thing that you know for sure is that if for some reason B plus C will be more than the maximum unsigned long value, then A will have an incorrect value. That's the only thing that you can guarantee. And this is a nightmare scenario. You can solve this problem in two ways. The first way is to introduce a numeric variable that will hold any number up to 10 to the power, to the power, to the power of 100. This specific number has a name. It's called Google. The total number of atoms in the universe is this, meaning a 1 with 50 zeros. You can even think of a variable that could go up to this value, meaning a 1 with goggle zeros. Google zeros. A 1 with Google zeros. Well, that's a real huge number. You can try this, but still this problem will remain. Yeah. And if you try this, then simple calculations like 2 plus 1 will take up more computer time than needed. So this is not something that you would want. So this is one problem with a simple thing like addition. But now, let me change the data types to this creature. I have been told that if you put a product on the American market and this product is able to do accounting stuff and this data type is used in your source code, you as the responsible company, person, CEO, you can end up in jail if you don't pay the fine. Because if all variables are doubles, then this addition, the sum, can be whatever. Even if you work with something like long double. this does not solve the problem. Huh? So if you want to work with fractional numbers, like a number like becomes like 1.3, huh? And C becomes 1. Just naming something, huh? And you want to add these two, what will be the outcome? You tell me. So, in the programming language C, we have so far encountered two problems. One with the concept of the operator, which will always operate. And give an example. Give an answer. Huh? And the answer might be wrong. And the problem that there is no way to handle fractional numbers. No way. And how to solve this? Well, for this I have come up with the idea of the micro. And I will read out and let me tell you something about the Xcode project. The whole project is called px, and internally it is divided into several levels of complexity. And the most simple level is the level 0, consisting only of these files. Not much, don't you think? I won't go into the content of these files, but not at this moment. And level 1 is a little bit more complex. Level 2 even more. And the top level contains all the software that I have written for customers. It's not the most beautiful software, but it was software meant to make money. And the idea was to slowly move all the functionality from this top level, the most complicated level, to one of these levels below. And these levels, so far, 4 levels have been implemented. And these levels are aesthetically okay software. Because the aim was to create software that is reliable, understandable. And for this it is needed that it is easy to read under all circumstances. And now you are looking at something what is totally not px-like. But I did some testing with my SQL. Well, we go to px1, and there's a section px1micro. For your info, this folder is called px resource, and it contains folders itself, and one of the folders in the resource is the source folder, and the source folder has the same structure as the px project in Xcode. And here you find the source files. The same files as you can find here. Yeah? And I go for the header file, px1micro.hpp. This header file I have written this year, the 15th of July 15th, 2019. It's an ISO date format. Well, the micro, I will read out loud. This class represents a numeric value. These values can be large integers up to 4g times 4g and fractions. The large integer values are needed to store primary key values of records. The fractional values are needed, for instance, to hold amounts like dollars, euros, and grams. And the primary key, if you're not familiar with that term, a primary key is a meaningless column in a database, in a table, I should say. And here you have the primary key. Its name is, can you read it? It's hard to read. ID, it states. Yeah. It's the YouTube archive movie _ primary key. It's a meaningless number. But in databases, if you want to work with databases, every table needs one column, which is to store the primary key of the record. Now, primary keys can become very, very, very large, of course. And for this reason, we need to be able to store large numbers, and these primary keys are most of the time consecutive numbers, and they are integer values. So no negative values, no fractional values, just integers. Yeah? And amounts like dollars, euros, and grams, that's $10.19. Huh? Well, all the calculations with these values are done integer-like. Huh? No floating point. Absolutely not. This means a 100% accuracy. So that's goal number 1. The smallest amount that can be stored is 1/1,000,000th. Hence the name px1micro, micro being 1/1,000,000th. And then it comes, there is a built-in mechanism that will protect from overflow or underflow. Both cases will raise an error. So if for some reason, somewhere in the application, two values are added, and that produces an overflow, then an error will occur. And the whole process will stop. The user will look at a screen, hopefully totally unfamiliar to him or her. It will be something like the blue screen of death. Because an overflow is not the, well, it's the end of the train ride. And the same holds for an underflow. Yep. So we have so far reached 2 goals, meaning a protection against overflow or underflow, and 100% accuracy on doing fractional calculations. Well, let's see how this works on the inside. This is the struct that you have to declare to work with such a value. And a declaration should be like px1micro A. Then you have declared a micro with the name A. Well, if you declare a micro, you can directly enter a value. For instance, you can enter a double value. So you can enter, 3.1. Then the value of the double will be converted into an integer. What you can also do is that you can enter the value like a string. a piece of text, 3.1 between quotes. That one is over here. px1micro with a char pointer, a character pointer. This declaration of the constructor of a micro refers to this one. No, that's not totally true what I say. But it doesn't matter. You get the point. Yeah? These are all the constructor functions. And of course you can just define a micro as a micro. It will be empty. That's the only thing what will happen during the declaration of a micro is that the fields will be made empty and the fields are put together in a substructure just for aesthetics. px1 micro data. And here you have it. This is the integer part. This is the fraction. More about it later. This is a byte telling whether or not it's negative. That is the exponent, the exponent. If you want to store a Google in it, in a px1 micro, it's possible. You have to type in Google. No, Google is equal to 10 to the power 100. And it will store it will store Google. Yeah, weird, isn't it? As for now, it is not yet active that you can work with these exponents, but it will be in the future if needed, if I am given time to program. The infrastructure is there. Huh? This input, 10 to the power of 100, will be stored as the integer will be 10, the exponent will be 100, and exponent negative will be 0. Its negative will be 0, its fraction will be 0. Yeah? Right. Well, let's have a look at the implementation of a certain function. And let me go to the function clear. Yeah? For this I go to the C file. This is how a typical px function looks like. Clear. A function returns a px status. And in this case there is only one return, as stated here, px OK. This means that the execution of this function, clear, of the struct px1micro has ended OK. And what happens is that the integer part, the fraction part, the negative is all zeroed out, exponent and exponent negative zeroed out. 5 fields given the value 0. That's Well, there is another function, and it's called check integrity. Which checks if it is still okie dokie. Huh? And the real function which is implemented is a normal px function returning px status. It is named check integrity, and it gives a Boolean result. 1 means it's okay, 0 means it's not okay. the second implementation of this function returns immediately the Boolean value. So check integrity without any parameter will return a 1 if the integrity of the structure is okay, and a 0 if the integrity of the structure is not okay. So let's go back. If you ask if the structure is empty, it will first do, if there is a debug mode, px debug, and it will ask, it will check whether the function check integrity returns the value 1. And it does this by this macro. More about the macro later, and this macro also. Yeah? Well, is a micro empty? Well, it depends at this moment on two values, namely, is there an integer part? Then it's not empty. If there's a fraction part, then it's not empty. In all other cases, it's empty. And here the check integrity function itself first of all, there's a macro, it's called px byte or boolean, and this checks this pointer. I will keep a different episode on how these px and px a means always. There's also a px meaning debug, and some variants, but this will come on later. Yeah? And now the integrity check itself, the fraction needs to be a number smaller than the micro's base, and the base value is the maximum value for the fraction. Sorry, I didn't mean this. I meant to go here. And that is this number. A 1,000 times 1,000. Yeah? That's a millionth. Yeah? So the fraction needs to be an integer number smaller than 1 million. Thus the maximum value for a fraction is 5 nines in a row. Well, the byte telling that it is negative has a maximum value of 1. It can be negative, then it should be this which be 1, or it's positive or not negative, and then it's 0. Yeah. And then if its exponent is negative, same structure. Now here I have stated that its exponent should be less or equal than 100. But this is of course not really, not technically a limit. But it's for the moment. Huh? Now, here's some more funny stuff. If the microdata has no integer value and has no fraction value, then it should not have a byte, a value 1, in the field it's negative. Because if 0 cannot be negative. Agree? So, that's a rule. Comes in handy. This is also, it's PX and the art of programming. This is what I call programming art. Is thinking about your problem. Of course, 3 plus minus 0 or 3 plus 0 both end up with 3. Huh? but 3 times minus 0. What's that? 0 or minus 0? You don't want to ask yourself these silly questions. All the behavior of the software should be carefully planned, calculated, and thought about. Well, and if there is no exponent given, and not something like 10 to the power of 100, then the exponent negative, being negative, should be 0 also. Consequently, of course. Well, if the software comes through all these lines, then it will reach the one but final line, and it will return, it will put the value 1 in the result, yeah? And it will return the value px OK. Well, and then we start with the testing. And here we can see the micro in action with some small testing statements. And the test software starts at line 57 and ends on line 1180. So we have about 1100 lines of test code. If you look at the actual coding, this is the actual code. It's about 80 lines. This is about 330 lines, a total of 400 lines. This is a bit larger. 680 lines, so 1000 lines. And this one, 363 lines. So the test code is about, in a number of lines, about 80% of the number of lines of real code. And the real code consists of these statements also. If debugging, then check integrity, see that the result is checked. The result should be a valid pointer, and the content of the pointer should be 0. And then here we have again debugging statements. So in this simple function, and it is 18 lines, if I'm not mistaken, 17 lines. 17 lines, and of these 17 lines, these 4 and these 3 are debugging. So just check. Check it again. Meaning about 40% of the lines are debugging lines. Here you have the same. Is the content a valid number? 4 lines, so the total number of lines is 27, of which 4, 7, 10. 27 lines and 10 lines of debugging statements. Let's go back to the testing. This is a test that I've added recently. When doing some bigger tests. And I discovered some, what you call it, it should have been in the test code. But who can think about it? Well, this, for instance, went not so great. Micro value set. Yeah. But let's see what happens. Yeah. Oh, and one thing about what happens here. This is the execution macro. I will go into that in a later stage. But every function returns a px status. And the px status is evaluated by the execution macro. So we don't call macro value set directly. A macro value set is what is called here in the constructor. And they are declared here. Yeah? Radio. Yeah, let's do a run. I can switch to only level 1. I can switch to level 0, but then level 1 won't be running. So I switch to level 1 and ask for a run. This micro called M is defined by this macro. More about these macros later. They're not so complicated. Huh? Value set, of course, there is a string given. Then it will go to this one. And then we are here. So we have a character pointer, the value, the length of the pointer, and whether or not the setting of the macro went successfully. Because it could contain whatever. Blah, blah. Now, what happens is, first of all, we check that this pointer is filled, so it's not a nil pointer. And the success, the address to store whether this was successful or not, that this pointer is okay. Okay byte, okay boolean. And here we have the clear function. I've talked about it. It just clears it completely. And then we have a nifty one. If there is no length of this character pointer, then it's then we can quit. And we did a successful interpretation. And the program, the function, did a fine execution. px okay. Well, if we continue, then on the debug, we wonder whether or not we have a len. And now you might argue, well, this is paranoia. This is not paranoia at all. Because if you look at these 7 lines of code, this is px and the art of programming. There is no way in your mind that you can fantasize that the processor will ever reach this statement when there is not a len. Because if there is not a length, then the processor will meet this statement and just return. Huh? And here we check whether it has a length. Why do we do this? Well, because I might have selected this 4 lines of code for some reason, because I think at the time I want to copy it to a piece of documentation, or I want to copy these lines to paste them in another piece of software, whatever. And then the phone rings, and I pick up my phone, and something, it's you. Whoa, hold on a second. Yes, boo, 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 boo. And in the meantime, the cat comes along and walks over my keyboard. And then I hang up the phone, and I ask myself, okay, where did we go? Oh yeah, I know where I was, yeah. But I do not see at that moment that there are 5, 4, 7, 8 or 29 lines of code missing. The cat walked over my keyboard. And the cat hit the spacebar. That is the reason why code is entered, why debugging code is entered all the time. And in this specific case, you might wonder, well, if you selected these 4 lines, you might have selected these lines. And then if the cat comes along, and then all these lines are gone. Yeah. Okay. Yeah. You're right. But still, it's about the art of programming. That if these 4 lines go missing for some reason, then these 3 lines will tell you, by raising an error, that there is something not right. You get? Now, we have reached 1 hour. So I will start a next episode in telling you all about this lovely piece of code. I'm very proud of it. So it's written in such a way that the C compiler will produce a very fast interpretation of texts into numbers. It even it's almost blasphemy, don't you think? Go to. But that's the art of programming. There is a rule in software land. Never use goto. This is completely wrong. Goto is an excellent principle. It has to be used carefully. But it can solve. It can produce very easy to read code by just using a goto statement. Well, more about this function, this micro value set, the next time, where we interpret a value and a length, and then return whether the interpretation was successful or not. Thank you so much for listening. Many episodes will follow. I have started this project in 1988. I have moved many prototypes to the trash. And the last prototype that I moved to the trash was in December 2000. And what I then started to write is what you are looking at right now. Yeah? Right. Well, I want to thank you from the bottom of my heart for listening and all your attention. And I hope that you will look at another episode of PX and the Art of Programming, because there is more much more to come, and you will learn what the art is of programming, and you will improve your own programming style. And by improving your style, you can set up your own style. I don't mind. But by improving your style, you will improve the quality of your code. And if you improve the quality of your code, you will bring smiles on the faces of the customer. And it will bring a smile on your face if you look at your bank account. For those who want to make money with programming. See you next time, programmers.